Something like this is almost mandatory in every one of our experimental shops, repair shops. And sometimes you say to yourself, I wonder if that's an accurate reading. Well, the easiest way to verify the accuracy of a meter used in a shop like I have, is to just compare it against another meter. Well, you say that means I need 2 meters. Well, yeah. Most shops or hobbyists' playground need 3 meters. They need 1 meter to measure voltage, 1 meter to measure current, and perhaps a second voltmeter. You need this kind of setup in case you're servicing a power supply or playing with something that requires voltage and current measurements simultaneously. Now, these days, you don't need to have a very expensive meter to get reliable, at least voltage measurements. Most of the meter reviews being done today are looking for build quality and input protection. And that's important if you're working with line voltages or high currents all the time. Moderately high, up to 10 amps. And even at 10 amps, this thing probably, most meters, are rated for intermittent operation. With microprocessors and post-construction digital calibration, most of these are not adjustable and they're virtually throwaway. So with 3 meters, and they don't have to be identical, you can compare or simultaneously measure a voltage and make sure that they're all within reason. Resistance, well, that's a little bit different. You certainly can measure the same resistor 3 times. You can't measure it simultaneously. For just a little bit of money, you can buy a resistor with known values, at least known well beyond the capability of a handheld meter. And some bench meters. If you want a standard value, 100K, 10K, you're going to pay a premium for it. But precision resistors of odd values appear all the time on eBay for less than $5. I would recommend a resistor above 10K. Certainly above 1K. Normally, the contact resistance of these terminals, these probes, and the associated leads, is about 1 ohm. You can buy precision resistors ready to go. This has precision, inductor, resistor, capacitor. I wouldn't trust either one of these with something as simple as this. A correctly built little box like this will have a calibration certificate. This one may or may not be accurate. You see the resistor is say 180K, supposedly measured against a fluke and an adjuvant. And we're looking for 180K. We're certainly off less than a percent, more accurate than that. Remember, I said we were hunting for 180. So it's fluctuating one digit, the last digit. Can't ask for more than that in a meter that probably costs $30 or so. If you have access to, or you know somebody that has access to something like this, you could periodically check these values. Now, they don't make this version anymore. When I bought this, it wasn't very expensive. It provides 3 different resistance standards, a voltage reference, and a current reference. And what I consider to be a real calibration certificate. It has a date. It has a serial number. It actually has a calibration temperature, which it should. And then these are the measured values. And they give you not only the model of the calibration device, the due date, and the serial number of the adjuvant device. And this company's certificate for this meter. There's this certificate number. So not only do we have a serial number board, that's it down there. They do, even though this model's obsolete, this DMM check. They do offer recalibration or restandardization. So let's see how this little thing does compared to this meter. This was last calibrated in 2014. So this is designed to be hooked under or clipped to. There again, this meter's within 1 significant digit of 5 volts. Good enough for the work I do. There is a current standard here, and it should put out, well, they measured 1.002 milliamps. So we'll go to milliamps. It was supposed to be 1 milliamp, and it's measuring 0.99 milliamps. We have 3 calibrated resistors in series. So the intention is just to go across the leads of the resistor with the leads of the meter. So we're looking for 100K. Again, well, there's pretty good. Or 9.998K. Well, 9.99. Again, we're off the last digit. And 1K. Okay? So that's $1K. This is a volts ohm milliamp standard. It would really be called a transfer standard. This pot is used to set the voltage output, and I don't have anything accurate enough to move that pot. When this was available, it was available for $40, $45. I looked at their website recently. They have a deluxe version of this, which now has an AC reference output and perhaps a frequency reference, although I'm not sure. But it went up to more than $100. Then we have something like this. It's an 8584. It's got 4 different outputs. I don't know if this is available on eBay or not. Outputs were selected by this jumper here. When this was available, it was available for $4, say $5. I don't know if this guy's still in business. Oh, this good old Alice. We have this one. I'm not sure what battery that takes, or whether I can power it remotely. Probably. So the output is available. Well, the output is selectable by these jumpers. And you can either stick a probe in these holes or loop it under these 2 measuring loops. When that was available, and it may still be available, when I bought it, it cost $7. So that's the seller. The last voltage reference is this. I think the blinking light indicates that the internal battery's bad. This one also has a calibration sticker which has no serial number on it. Neither does the device. So, I mean, who knows what it really means. When it was working, I could change voltage by pushing this button. And one of the LEDs would remain illuminated. And when I bought this, it cost, again, it's an AD 584. What it cost? Free shipping cost $20. And probably in 2014 or 15 was available from this guy. The reason it has a bad battery, or I suspect it has a bad battery, is because I don't use it very often. In addition to this meter, I can see 3 other meters here on the bench. I think I have 1 or 2 more somewhere. But just for fun, so this says 50 nanofarads, 50.6. Standard is 50.2. So for 20 bucks, you get some sense of calibration using this standard. Let's take a peek inside. Now, I don't want to handle this once it's been measured. You've got a coil. Looks like individual insulated wraps. It's obviously insulated wire, but each wrap appears to be spaced. It's got some sort of a precision resistor and a pair of capacitors in parallel. Well, I hope you enjoyed that little blurb. If you did, subscribe, give me a thumbs up, drop me a comment, at least come back. Thank you.